Hello students, welcome back. So in this video, we are going to learn what exactly is autopsy, how can we do forensic analysis with the help of autopsy. First of all, let me introduce you to all what exactly autopsy is. Autopsy is basically a digital forensic tool which is designed by SleuthKit. So it is part of the SleuthKit forensic toolkits. This particular tool comes very handy because it can be used by law enforcement agencies, military agencies, or even for personal forensic investigations. Using this tool autopsy, you can actually recover the data from your evidence drive. This is quite similar to the tools we have seen so far, but autopsy can be used from the analysis point of view as well. As you know, autopsy is basically post-mortem. So in short, you are trying to recreate the crime scene after it has happened. So to gather as much intel as possible on what must have taken place on the crime scene, how the crime scene was facilitated, how the crime had actually taken place, what were the various tools which were used to conduct that crime, what are the various evidences or traces of evidences left by that attacker on your machine. These all minute details can be fetched out with the help of autopsy. So let me tell you the various features of autopsy. Autopsy can be basically used for hash filtering. Autopsy can be used for keyword search. It can be used for metadata analysis. It can be used for timeline analysis, when and where a particular crime must have taken place. Autopsy can be used for data carving also. A similar tool which we saw just before this particular tool, that is bulk extractor. So it can do all such activities with a single user interface. Autopsy in Linux comes as a command line tool, which generally is hosted on a local host on the computer itself. So you will be able to open the Autopsy web host and you will be able to carry out all the activities on that web host. Similarly, Autopsy also has a Windows equivalent. So in this video, I'm going to show you both the implementations, that is the Linux implementation as well as the Windows implementation of Autopsy. So without wasting much time, let's start with the Linux implementation of Autopsy. So to open Autopsy, you simply need to do one thing. You can right click on the desktop, go to applications and go to forensics, then go to Autopsy. And then you can go to this local host that is created for you. If it gives an error like this, unable to connect, you need to go to the second option. The second option is opening Autopsy with the super user credentials. So type sudo and then type autopsy, press enter. You need to type in the password of Kali, that is Kali itself, and now it should do the trick. Yes, as you can see, so you need super user credentials to run Autopsy. Fine. So this is how Autopsy looks like. This gives you a GUI using which you can do your task easily. As we are working on the first case, so we need to click on new case. If you have any queries, you can simply go to help and check their documentation. It consists of documentation on each and every analysis type: file analysis, metadata analysis, data analysis, etc. etc. So let's go back and click on new case. Case name. The name of this investigation, it can only contain letters, numbers and symbol. So let me give it a name, case 1. Description, an optional one-line description. It could be analysis of pen drive. Let me be more specific, analysis of 16 GB pen drive. Then investigator's name, it can be my name. Then press new case. This is just for maintaining the chain of custody. Next up, it is asking you to add a host. The host name is basically the computer on which you are running the investigation. So it could be your name or your computer's name. So I will type something like this, Sridhar's laptop. It could be a one-liner description. I can keep it blank. It is optional. Similarly, time zone. Time zone is also optional, but I would prefer entering the time zone because it will help me in analyzing the particular time when I have actually gathered the information, I have actually started the investigation. This will help me from the chain of custody point of view. So I can keep it blank, or I can search for the time zone and enter it over here. An optional time zone value so and so is given. Let me check the documentation and let me show you how to enter the time zone. When creating a host, you can specify a time zone. Okay, so let me search for Asia and Calcutta if I'm not wrong. That is Indian Standard Time. So Asia, Calcutta, yes, it was selected. Copy it, go back over here and paste it. Then point number 4 is fine. I don't want to add any skew. I don't want to add any adjustment of -10 plus 10 seconds. It's fine, totally fine. 0 is fine. Fifth option is part of alert hash database. So basically, this is selected if any bad file or any bad sector is present on your evidence drive, so that those files can be omitted without any issues. I don't have any bad sectors, so I will ignore that. Similarly, an optional hash database of known good files. Obviously, all of the files which are not bad will be good, right? So these two parts are optional. This will eventually add a lot of time to your investigation, so I will omit these two steps. If you know which are the sectors, which are the files which are bad, if you know which are the bad sectors or bad files, you can add those files over here, but at this point of time I don't need these two values, so I will keep them blank and click add host. Okay, adding host Sridhar's laptop to case 1. Host directory is created over here. Configuration file is here. We must now import an image. So now click on add image and this will be your evidence image. We know that the image is present on my computer. So I will click on add image file and I will have to give the path of it. So let me go back and see the path of that image file. It was present over here. This is the path, this is the image, sorry. So click on properties, copy the entire path, followed by the file name dd evidence.dd. Next is type. Please select if this image file is for a disk or a single partition. It was obtained from a pen drive, so it will not be a complete disk. It is basically a partition. So click on partition. Import method, I will be copying it. Kindly read it. To analyze the image file, it must be located in the evidence locker. We don't have any evidence locker, right? We are simply performing it on a virtual machine. So I will copy the entire evidence and then I will be performing all the analysis on that copy. So it is always better to select the second option, that is copy. It will make sure that you don't end up making any modifications to the actual evidence drive. Then next. Next up, this is the local name of that evidence drive. Data integrity and MD5 hash can be used to verify. Now it is the step when we should be calculating the hash values, so that at the end we can verify whether our hash is genuine or not. You can always click on verify hash after importing, and then the mount point, it's fine, no need to change it. Press add. Now it will take a lot of time because we are calculating the hash value, so it will go through all the files one by one and then it will compute the hash and then it will go to the next step. So till then I will pause the video and I will be back when it is done. So as you can see, the MD5 calculation is done and this is the MD5 that has been calculated. For your reference, I have already taken the hash value of this particular evidence way back. Let me show you the MD5 value which I had got earlier. Okay, so this is the MD5 value which I had got. Let me zoom this up, or let me increase the font. This is the MD5 value of the evidence drive that I had calculated while we were actually fetching the evidence from that digital media, that is my pen drive, right? So let me copy this value which we have just now got and let us compare if they are same or not. We will excuse the lowercase and uppercase thing. It is not case sensitive. And as you can see, these two values are exactly identical without any single change, without any single bit differing. So this basically means that the evidence that was present earlier, that was actually captured from that pen drive, and the evidence which I am now feeding into the autopsy engine for analysis is exactly the same. So there is no change in the evidence between the two steps, that is acquiring the evidence and storing it and forwarding it for the analysis part. So that is why chain of custody is very important, because now if I get some hash value which is different from this, I will surely make a conclusion that there might be some changes which have crept into it, or which there might be some changes which have actually made way into the evidence drive. So the analysis will be totally waste, and because we won't have any integrity in the data. That is why the hashing is very handy whenever we start analyzing any evidence. So the MD5 hashing is done. Now it is testing the partitions. It is copying the images into the evidence locker. We are now creating an evidence locker which will actually store all the evidences. That will be nothing but a copy of the actual evidence where all the analysis will take place. And we will not do any analysis on the real evidence, just to avoid any further modifications to it. So let this happen in the background. I will again pause this video and come back whenever it is done. So after waiting for approximately 10 minutes, the process is done. As you can see, it has already copied the images into the evidence locker. The image file is added with this ID img1, and the volume image is so and so. Now what you need to do is you need to click on OK. So now our evidence locker is consisting of that image which we had created way back. So now it's our turn to start analyzing this evidence. How to do so? As you can see, there is a button analyze. You can click on that, but before that, let's go through all these options available. First one is file activity timelines. These are basically used to record the various activities and their corresponding time. Whenever you have performed an activity, you can record that over here just for chain of custody purpose. Next is image integrity. If I click on it, it will basically tell me the hash value of that evidence drive. If I click on validate, it will check and tell me the original MD5. So at any point of time, if you feel that the evidence drive has been tampered or the contents are modified, you can simply click on this file system images and click on validate. If both of these hash values are different, you will come to know that there is some change which has taken place in the evidence drive. It's very handy. It will tell you that the evidence drive has been tampered with. Fine, let's go back. If you click on this hash databases, it will basically point out to a documentation of the various type of hash values available. As we had seen earlier, the hash database will consist of bad sectors, good sectors, and the overall hash of the entire file. So this is just a documentation. Next is view notes. It will show you the various notes that you might have created in between. As we have just now started with the analysis process, there is no note created. So whenever you feel like adding something, adding a note, adding a text during any checkpoint during the investigation, you can do so, and all those notes will be visible over here. Similarly, if I click on event sequencer, it will allow you to add certain events. For example, today I am starting with an event, so you can say that the investigation begins and then click on add. That's it, and it will be basically pointing to a particular event. It's that simple. So these are some optional things. The main task which we are interested in is the analysis part. So let's click on analyze. As you can see on top, there are few options: file analysis, keyword search, file type, image details, metadata, etc. So these are the various types of analysis that you can perform in Autopsy. Let me click on file analysis. These are the various files present in my evidence drive. So if you remember, in the original evidence drive, we had only 5 images. If you want to cross check, you can just go back to the first video, that is static data acquisition from Windows using FTK Imager. In that video, we saw that the original pen drive consists of only 5 images, that is this one, this one, this, and this. So it will show you that these were the 5 images present in the pen drive. But apart from that, there are some hidden data as well. Hidden as in these are the files that may have been deleted. These are the files that may have been orphaned. So we can get to know what are the files which are hidden somewhere. So we can get to know what are the files, what are the directories which were orphaned or which might have been deleted. So as you see on top, FAT1 and FAT2, they are huge in size as compared to these actual images. So there is a possibility of something hidden inside it. So if we click on FAT1, it looks something like this in its ASCII representation. If I click on Hex, it will look something like this. So ultimately it is now up to the analyst who wishes to dive deeper, and using some hex editors he or she will be able to find out what's actually hidden inside these files, that is FAT1 and FAT2. These are basically some orphaned files or deleted files. Similarly, so on the top you can see there are 3 columns: written, accessed and created. These are nothing but the timestamps associated with each file or fragments or partitions. So let us consider one of these files, this one, download6.png. If I click on this, this is how the image will look like. So let us understand what is the difference between these 3 time columns. First one is written time. So the written time is nothing but whenever the last time this particular file was modified, it is that time itself. So it is irrespective of whether the file is present on your hard disk or on your pen drive, it is the last time recorded whenever this particular file was modified. Fine. So it is 4th of January 2021. Next is accessed. Accessed time is nothing but whenever the file was read last time. So it is nothing but 8th of April 2021. After that, this particular file was never read or never opened. Similarly, created. Created time is nothing but whenever this particular file, download6.png, was actually mounted on your evidence drive or your pen drive, it is that time. It looks quite similar to this written, but the written time is whenever this image was actually created, irrespective of whether it was copied on your hard disk, your pen drive, or it was sent via mail. Whenever this particular file was created, it is that time. But created time is the time at which the particular image was mounted on your pen drive. So obviously this will be later than the actual creation time. So using Autopsy, you can actually find out what was the time when this particular file was created, what was the time when this particular file was updated, etc, etc. So this comes really handy during investigation processes. So this was all about file analysis. Similarly, there is one more option on top, keyword search. So this is how the keyword search GUI looks like. It is very simple. It is like a normal search. If you want to search certain string or certain text from this particular evidence drive, you can simply search that particular word over here, for example Gmail, and then press search. It will take some time because it is having a long list of files, it is having lots of data, so it will take some time. So we won't waste time. I will just click on it and let it work in the background. In the meantime, let me open this third option in a new tab. So over here you can search the various files by the type, that is the extension, that is the type. You can sort the various files according to their extension types, but obviously there's a warning that this can be a very time intensive process, so do this only when you have a long time in hand. Clear? It's very simple. Whenever you click on this sort files by type, it will start sorting all the files by their extensions, and that is it. But it is going to take a long time because it is approximately 16 GB in size, so it will sort all of these files based on their extension, so it is going to take a long time. So let it work in the background. Similar to this, it is also searching for that file. So searching and sorting, very fundamental activities happening over here, but it's going to take a long time as the evidence drive is huge in size. Similarly, next analysis type is image details. So if I click on it, this is how the image details tab will look like. Let it open. So these are all the general file system details of my evidence drive. Its name is this. It's having so many free sectors, free sector counts, cluster data, etc, etc. So as you can see, these are the various sectors. If I click on one of the sectors, that particular sector will open up, and then I can start investigating on that particular sector. As you can see, this is system volume information, etc., etc., and this is nothing but the first sector. Similarly, I can jump to the next sector and so on. So these are all the sectors separated into various groups, and that's it. So this is how autopsy can be used for analyzing a particular image, analyzing an evidence, and trying to carve out useful information out of those. So that's it. This is how autopsy can be used for carrying out investigation, carving out metadata information, carving out the system time when that particular evidence was captured, when a particular evidence was modified, etc., etc. You can see that these processes are still going on, so I won't waste time over here. At the end, you will see whatever you had searched for, it will be shown to you, but it's going to take a long time. So I will stop the process over here. But how to close this case, because you need to move out of a case gracefully, that is very important. How to do it? You simply need to go to close. Wherever you are, simply click on close. It will move you out of that evidence folder, and then you can simply click on close host and again close case. Once this is done, you can simply go back to your terminal and press Ctrl C to move out of that terminal window. This is how autopsy can be used in Kali Linux. In the next section, we are going to learn how to do the same task using Windows operating system. So stay tuned. Let us now see how to install Autopsy on Windows and carry out the same processes that we had just now seen in the case of Linux. So for that, you need to visit this website autopsy.com/download, and depending upon your processor architecture, you need to download the corresponding file. I have a 64-bit architecture, so I have downloaded this file, and this is how it looks like. Once I click on this, the installation process begins. So let me walk you through the installation process. Once it is done, click on Finish. It's a very simple, straightforward installation. Just select the path where you would like to install it, press Next, 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 and done. Once it is done, click on Autopsy in the search bar, and this should open up the Autopsy GUI. It will initialize few modules for the very first time whenever you open it, and once the modules are downloaded, once the modules are initialized, it will show you an interface. It's a much better interface as compared to Linux, where you get a lot of options, where you can select and deselect the options you wish. You can start the investigation process with the click of few buttons, and your entire investigation process will be very simple. So this is how the Autopsy GUI looks like, and now let's begin our process. Well, to start a new case, click on this new case button, give it a case name, for example, first case, and give it a directory. I will like to save it on G drive. Let me check once. It is E drive, sorry. So let me save it on E drive. Then click on next. The base directory doesn't exist, so I would like to create that directory. Case number is 1, examiner name, my name, and rest are optional fields. Click on finish. This will create a database for your case that you're going to analyze. Let it happen in the background. It will quickly generate options. Yeah, these are the options. So let me select the type of data source. As we have a data source image, so I would be selecting disk image and then click on next. But as you can see, there are many options. It can be a disk image, it can be a local disk itself, it can be some logical files, unallocated space, etc., etc. So I would stick to disk imager or VM file.
then click next. Now give the path of the data source. Now as we know, we have the data source over here in this folder, this shared folder. So select this, click open, and then the time is automatically selected. Sector size is auto detect, it's fine. Hash value is optional. Okay, so what you can do is, you already have the hash values. You simply need to copy them and paste it over here. It will just verify whether the hash values are same or not, and then click on next. These are the various things which this will be able to, these are the various modules on which these scans will be completed. For example, hash lookup, file type identification, extension mismatch, etc., etc., email parsing. So as you can see, this GUI mode in Windows gives you a lot of freedom. You will be able to select or deselect any of the options. You will be able to select or deselect any of the options that you want or you would like to omit. So in this case, let me select all these modules and click on next. It's going to take a long time because all the modules are selected. So let it scan, and in the meantime I will just pause this video. Whenever this processing is done, I will come back and I will tell you approximately how much time does it take. So the process is finished. It took approximately 4 to 5 minutes. The data source has been added to the local database and the files are being analyzed. So now you can safely click finish. Now select this data source, and as you can see, on the left hand side there are n number of options available. For example, file types. So if I click on this, these are the various files and they are already sorted by extension. So you can see the striking difference between Linux and Windows. Windows makes it very easy to run this application with the help of the GUI. You don't need to go separately to the various options and then search for the extension types. As we saw in the case of Linux, it took a long time, but in this case only within 4 to 5 minutes the entire process is done. So now click on the by extension option over here, and as you can see, there are 6,817 images which are of the file extension JPG, JPEG, etc. There are 15 videos, there are 13 audios, 200 archives, 6 databases of the format .db, db3, SQLite, and SQLite 3. So there are few documents and executables also. So if I click on documents, here you can see there are 2070 HTML files, 738 Office files, and so on. So it's very handy, and as compared to Linux, I feel whoever is comfortable in Linux, they can simply use Kali Linux, and whoever is comfortable with Windows, they are going to stick with this Windows implementation because it gives you a really nice GUI feel, and you can directly interact with the application. So as you can see, if I click on this images, these are the various images present inside this particular folder. And let me open one of the images. And this is what the image looks like. Similarly, there are few more images, as you can see, 7,000 now to be precise. So let me click on any of the images, and as you can see, if that image is deleted, it will be simply shown with a cross over there, and it will be represented with the help of a hex value. Fine. It is still finding out images. It is still carving the images. It's not a complete process. It will keep on finding out the images in the background. As you can see, it is still increasing. The number of images is still increasing. It has now reached 7,672. So it is still working in the background, and it will keep on carving the images until and unless it is completely read. Similarly, there are these videos, there are these archives, audio, databases, etc. So these are the databases. Fine. So now you can just imagine how simple it is to carry out carving or carry out data analysis with the help of this tool Autopsy. Now, if you click on deleted files, you will come to know that there are these many deleted files. And if I click on this, there are these many deleted files, as you can see over here. Similarly, if you click on this result, that is extracted content, you will be able to see how much data we have been able to extract from that evidence drive. There are these many metadata files extracted, these many EXIF metadata extracted, It will obviously give you the latitude, longitude of those images where that particular image was captured, as we had seen in the previous video also, that we can make use of these latitude, longitude information. And also the device model is mentioned. It was clicked on Xiaomi Redmi 4. So you will also get to know which is the device that was used to click this image. Similarly, this was clicked using Motorola. So there are these many crucial evidences that you can capture using this simple free tool, Autopsy. Next, you can even look for some keywords if present. You can look for some hash values. You can look for some email messages, accounts, etc. So as you can see, this particular application is very handy. So that brings us to the end of this video, where we have seen a lot about Autopsy. Autopsy being a tool which is used for data carving, data analysis, forensic investigation, etc. We have seen the implementation of Autopsy in Linux as well as now in Windows. So in the next few videos, we are going to discuss about hashing, how we can carry out hashing with the help of freely available tools, and we'll see more such interesting tools in the future. So stay tuned.